Welcome back, and thank you very much for staying with us up to so far. We're now finally on our last question for today. Remember, tomorrow is a public holiday, so we don't come on public holidays, but we will most certainly be with you again on Thursday, so do wait for us then. But of course, you can actually keep yourselves busy with the math that we have on the app. Just download the Tenfold Education app. It will give you access to content for grade 10 up to grade 12 mathematics as well as science. So if you have that, it does actually touch on a lot of what we do here. It gives you a lot of basics and the background info from grade 10, grade 11 and grade 12's work. In addition, you can also use the app to interact with us here on this show, sending us your questions. If you don't want to send them on WhatsApp, or if you want to send them on our Facebook page, send them via that app. It's actually a Tenfold Education app. It's a very nice app. It will actually help you to work very well on this. So now we're going to go to a question that was sent to us by Matsiriso. Now I've got very good news for you, Matsiriso. You won yourself a 10-inch TV for just sending us that question. If you also want to win something, send us questions. You will most certainly win something. You'll never know who's going to win. So keep sending us those questions. You'll stand a good chance of winning something. So let's go to this. This is a wild card. Wild card is basically a question that is a little bit off topic, where we allow you the opportunity to send us anything across the math curriculum that is not necessarily in line with our topic for that particular week. So this one is a nice question that comes from Function. Let's go and listen to Matsiriso's question.
Hello Tenfold, please help me with this question.
Right, thank you for that question, Matsiriso. Let's jump right into it because of time. We don't have much time. The question says, we are given a function here that says, in the diagram below, the graph of f of x is ax squared is drawn. In the interval x is less or equal to 0. The graph of the inverse is also drawn, where p is a point, minus 6 is to minus 12. And this point is a point on the graph of f, and r is a point on the graph of the inverse function. So the graph of f is the original graph. We can all see that. It's the one that is passing at p, and the inverse graph is the one that is passing at point r. So the first question is asking us, is the inverse graph, is f to the power minus 1 a function or not? And you must now motivate your answer. Now, the inverse graph in this case is not a function, because if you use the vertical line test, if you remember, if I draw the vertical line test, there's many ways of actually looking at it. But if I draw the vertical line test on a function that looks like this, and I try to cut this and I cut it more than once, then it's not going to be a function. But the one we are looking at here, the inverse graph, if I draw a vertical line, it will most certainly cut the graph once. So because of the fact that it's going to be cut once, then it means it is a one-to-one function. So the answer to this question is simply yes, f of x. The inverse graph is a function, and the reason for this is because it is a one-to-one relation. Very important thing to keep in mind. We're now going to go to the second part of this question. The second part says to us, if r is the reflection of p in the line y equals to x. So there's a line y equals to x. If you allow me to draw it, the line passes where the lines meet all the way up to there. So if this point r here is the reflection by p about that line y equals to x, what will the coordinate of r be? So it's important for you to understand this. When you've got a particular point on the original graph, the inverse will just be the same point, just swapped around. Just switch everything. What is x becomes y, and what is y becomes x. So let's go and see what the coordinates of r are. If p, which is a point on the graph of x, is minus 6 and minus 12, then the inverse, the coordinates of r will just be minus 12 is to minus 6. A very easy question indeed. We're now going to go to the last part of this question, which is asking us to work out the value of a. If you go further down, it says calculate the value of a on this. Remember, for you to find the value of a, just use the function that was given to us, which is y equals to ax to the power of 2. Your y value is negative 12, a, and your x value here comes out as negative 6 all the way to the power of 2. If I simplify this, minus 12 becomes a into 36. Right, so if I divide to work out the value of A, divide this by 36, divide this again by 36, that cancels out. So A simply comes out as minus 1 all over 3. Yes, minus 1 all over 3. That is the value of A, which makes the graph of f of x to become minus 1 over 3x to the power of 2. Very nice and simple question. Thank you very much for sending us that question. It actually comes and refreshes us in terms of trying to figure out what is going on with functions and inverses. If you've got a function, to find the inverse, you just swap the x values and the y values. Whatever was x on the original becomes y on the inverse graph. What was the domain becomes the range. What was range becomes the domain. So you're just simply swapping anything that is x becomes everything that is y. So that is it for this week. Thank you very much for watching our program. We really enjoyed being with you. We're still continuing with calculus this week, even next week. Keep those questions coming in, but we have enough questions now for calculus. So you can start sending us analytical geometry from grade 11's work, as well as analytical geometry from grade 12's work. Remember, tomorrow we won't be with you guys, but don't despair. On Thursday, we'll be most certainly here with you from 5 o'clock until 6 o'clock. Make sure that you do stay with us and keep sending your questions to stand a chance to win awesome prizes if you do that. Until we meet again next time, it has been wonderful being with you guys. Enjoy the rest of your holiday tomorrow. It is going to be exciting for us to see you again on Thursday. Bye-bye for now.